So in the ideal situation, what happens is you get a bunch of vaccines that can be produced at huge scale for everybody who needs it in the world. And that when you give that vaccine to someone, they are then protected against this infection for, say, 5, 10 years or something. If you can get that, and it's a really big if you can get that, then you can start to think about a vaccination program to achieve what we've heard of as herd immunity, right? Now, herd immunity just means that so many people are protected against a virus or immune against it, that the outbreaks, when there are some, when the infection comes in, that it doesn't spread and an epidemic doesn't grow. The principle of a vaccine is simple. You basically fake an infection. So what you do is you either take a little part of the virus that doesn't cause any harm on its own, or you can even take the virus itself and irradiate it or kill it some way, inactivate it, and inject that into the body, or it goes up your nose in a nasal spray. The body will recognize it, even though it won't be harmful, the body will still prepare an immune response against it. So you'll have all these antibodies and other cells in your immune system. And the whole idea is that that immune response is sufficient and long-lasting enough so that when the real live virus comes along, when you pick up the bug, then your immune system's already primed and knows how to kill off the virus. It's as simple as that. What's complicated is all the steps involved in making a good vaccine, making one that's safe, and then getting it out to all the people who need it to protect against that infection. What's different with a vaccine than like a drug you might be developing for people with coronavirus is that a drug's going into people who are going to be ill, maybe even really ill, whereas a vaccine goes into potentially billions of people who are healthy. It has to be absolutely incredibly safe. Beyond actually creating a working vaccine, probably the biggest issue is how do you get it to everybody? I mean, in this country, shots of vaccine, they will go into vaccination programs and people will be given shots depending on who is deemed to be sort of most appropriate to get the vaccination at what time. You still then have to find a facility to build it, to make it, to churn out all these doses. And is this a one-shot vaccine? So if so, great, because you need half as much as if it's a 2-shot vaccine. Or, some vaccines, you need 3 shots of it, or you'll need, boosters and all sorts of things. There will obviously be some people who don't want to have a vaccine, for they may just not agree with vaccines or think vaccines are dangerous, full stop. But obviously the point is that the more people who do have an effective and safe vaccine, the better, because that will protect those people, elsewhere in the community. Something I expect to happen is that we may well end up with different vaccines for different people. And we actually already do this with the flu vaccine each year. Certainly in this country, the live attenuated flu vaccine, which is the most potent flu vaccine, is given to the kids, whereas the over 65s get a different type of vaccine. So it's not a straightforward situation that we'll have one vaccine for all by any means. So early on, in March, April, we had a lot of very prominent medics and scientists saying it's going to be 12 to 18 months before we get a vaccine. So that's actually massively accelerated compared to any other vaccine that's ever been produced. The fastest that we've had a vaccine out is for mumps, and that took 4 years. Dengue fever, the virus was identified in 1943, I think. The first vaccine was released in December. This December just gone. So why does it take so long? I mean, 18 months is still a long time. Well, the problem is for any vaccine, you have to go through 3 stages of trials. Okay, and these all take months. Often you have to look at the data after each trial, or even as the trial is ongoing, and you have to think, is this working? Do we have to make any sort of chemical changes to what we've got in the vaccine? And then do we have to go back and sort of start this again? It's entirely plausible that we will now be living with this coronavirus for a long, long time, years, whether we have a vaccine or not, because a vaccine is absolutely not guaranteed to get rid of the virus everywhere in the world. And as long as it's somewhere in the world, then it can infect anywhere in the world. That all sounds very downbeat and miserable. But what we haven't talked about, which is going to be hopefully really important as a third pillar to this, is the work on the other medicines. So unlike vaccines, which are trying to protect, things like antivirals and other kinds of interventions, so that when you do have people still going into hospital, that you'll have some treatment you can give to them. So this is the scenario we want to end up in, and I think is the one that's realistic to hope for, is that, yeah, the virus is still around in some places in the world, and we do get used to flare-ups in this country, but they are quickly contained and dealt with. And when people go into hospital, we at least have some treatments to give to them so that they don't end up in intensive care and worse, dying.